Okay, so this is class for Thursday, November the 4th, for my 30S Pre-Cal students. And we're going to do some questions out of section 4.3, page 236 in the textbook. And I recommend to the students to actually look at their solution real quick and then cover it up, close it up, and let's see if we can come up with it for ourselves. So again, this is page 236 of the textbook. Let me open it for myself too. And we're going to use this, we're going to solve these quadratics by going back to our chapter 3 toolbox. We're going to use complete the square. Okay, so a widescreen television has a diagonal measure of 42 inches. Hang on a sec. And a width of 16 more than the height. So let's see what's going on here. There we go. Determine the dimensions of the screen. So the first thing I want to do with this is make a diagram. So here's my television screen. And my diagonal, which is, by the way, the number that they always give you when they're selling you the television. When you look at the ad, it says it's a 42-inch television. That means it's diagonal distance. Why do they use this instead of length and width? Because it's always a bigger number than the length, so it makes it look like a bigger TV when they sell it to you, right? So the width of the screen is 16 more than the height. So if this is the height, this is height plus 16. Determine the dimensions of the screen to the nearest tenth of an inch, okay? How do we approach this problem? Dimensions means find length and width. What we've created here is a right triangle. And what can we use to solve the right triangle? We're going to use Pythagoras for this. So h squared plus h plus 16 squared, right? Leg squared plus leg squared equals hypotenuse squared. That's going to be h squared plus 32h plus 256 equals, and I don't know if I know 42 squared off the top of my head, so I might just go and get my calculator out to help me here. There we go. Clear, clear, clear. What's 42 squared? 1764. Gotcha. 1764. And when we're solving a quadratic, we want to move everything to one side, right? So 2h squared plus 32h. And then I might again use my calculator because the numbers are kind of big here. So 1764 minus 256. And that's 1508. But it's a minus 1508. Okay? And even though I'm going to complete the square, because there's 0 on this side and all three of these numbers are even, I'm still going to divide out the 2 first. Always look for that common factor first if you can. It makes your life so much easier because your numbers get smaller. So I'm going to divide both sides of the equation by 2. And just to make sure I don't goof this up mentally, I've already made a couple of mental math mistakes this morning. 754. And here's where, in the problems I assigned you in the last section in 4.2, pretty much all of them were fairly easy to factor. 754 is getting kind of tough. What two numbers times to make 754, but they're 16 apart? I don't have that mental knowledge, and I don't feel like playing with it. So I'm going to use my other tool from my toolbox. I'm going to complete the square. Completing the square is always easy, too, when there's no number in front of h squared other than 1. So all I have to do is figure out what actually completes the perfect square if the b term is 16. And remember, what I do is I just take 16, divide it by 2, and then square that answer. Right? So that's 8 squared. So that means I need a 64 here. But I can't just add 64 to the equation. So I minus it again right away. And now I haven't changed the equation any. Because really all I added was 0. Adding 0 doesn't change anything. Still the same equation. Now, I keep this 64 in the bracket because it's part of the perfect square. But this minus 64 I take out of the bracket and combine with that 754. So I have that 754 here, and I'm going to add 64 to it. And that's 818. So minus 818. And then this, of course, is h plus 8 all squared. And now the algebra is pretty easy. It's just grade 9 with, well, with a little twist because we got the squared, but opposite operational procedure, right? How do we isolate h from here? Step 1, get rid of the 818, so add that to both sides. Step 2, I have to square root both sides of the equation. And that, of course, does give me the plus or minus. I'm going to write it down, but I already kind of know that the negative doesn't make any sense here. I'm looking for the length and width of a television. Putting negative numbers on that doesn't seem to make any sense to me. So I'm going to ignore the negative possibility and say that h is whatever the square root of 818 minus 8 is. And that's an exact answer. I might try to simplify it. Can I simplify that? No, what's the biggest perfect square in 818? Doesn't have a 4, does it? No, 816 would have a 4. So it doesn't have a 4. Does it have a 9? No, 8 and 8 is 16 plus 1 is 17. It doesn't have a 9. You know what? That might be simplified. It might not have it. It doesn't matter. We're going to get a decimal. So we're going to get a decimal for that. And so I'm going to go to my calculator. So let's say we got 818 square rooted. So I'm going to square root. Actually, 818 was the last number I had, so I'm just going to use my answer button. Answer. And then minus, oh, wait, oh, hang on. Oh, funky, fancy calculator. Close that bracket and then minus 8. Otherwise, it thinks I want to square root 810. There we go. And that gives me 20.6. And what are we in again here? We're in inches, 20.6 inches. And so therefore, the dimensions of my television is, the TV is 20.6 by, so you could just use an x instead of by. And of course, if that's the height, then I have to add 16 to that. So 36.6 inches. And there we go. And now I take a quick look. Is that what it was when I looked at it before? It does a little bit of talk in the book about extraneous root, which I kind of knew back here when I got rid of that negative. But yep. And that's how you should use a textbook when, and this is going to happen to you a lot. Not so much here in high school, but there will be sections. Right now, my kids are going through a strike, 2 of them at the university, right? I have my oldest son's in his 4th year of mathematics, and my youngest son's in his 2nd year of biology. And some of their profs have just loaded up Learn with stuff for them to do on their own. They have to learn from a book. So that's a reality of the education system, is that there won't always be people there to explain things to you. You're going to have to rely on books. So this is how you do it when you're learning from a math book. You run the examples yourself, just using the guidance of the book when you need to. Okay? Any questions about that one? By the way, in the real world, we would never say 0.6 of an inch. You know how we would deal with that? Let me show you how we deal with that. We would take our calculator, and we would minus the 20. So we have that decimal of an inch. And then we'd say to ourselves, that's a half an inch plus a little more. So rounded to the nearest half inch, you could say that that is 36 and a half or 20 and a half inches. But if you wanted to be more accurate than that, you could say that it's closer to 3/4 than it is to a half. Am I right about that? Actually, you know what it's really close to? It's close to 5/8. Because 5/8 is 0.625. So 0.6 and a little little bit of change is actually closer to this number. So I would say that it's actually closer to 20 5/8 by 36 5/8 of an inch. That's what I'd say. And you might say, well, you rounded up to get to that because it wasn't 0.625. I said, but yeah, but you round up all the time. I'm trying to sell you a TV here. I want to make it look as big as possible. Jeez. All right, so there we go. There's the first one. Let's do a couple more. Solve this one by completing the square. This one doesn't have a context. It's just to solve by completing the square. And you'll notice that this time, the book does this a little differently than we did. The book likes to put the constant on the other side. So their first step is to add 10x to both sides and add 21 to both sides. And then, instead of adding and subtracting the same thing right away, they actually just add it to both sides of the equation. There's nothing wrong with thinking about it this way. You still have to think what's half of 10 squared, which is 25. But you add the 25 to both sides of the equation. And then you end up with x plus 5 all squared is equal to 21 plus 25 is 46. And then away you go. Square root both sides. And again, you have the plus or minus. There's no context here that would tell you to eliminate the negative. The negative is technically one of the answers here. So my exact answer is -5 plus or minus root 46. And we saw this a little bit in chapter 3 when we were finding x-intercepts. That's the exact answer. Any attempt at a decimal answer is an estimate, right? Because you rounded it somewhere. Because we know what kind of a number is it when you square root a number that isn't a perfect square. You get an irrational number. There is no end to an irrational number's decimal. It's not like if I wrote enough decimals, I'd finally get to the last place, right? No such thing. So that's the exact answer. As an estimate, if you're not allowed a calculator, you'd be thinking to yourself, I'm going to benchmark this. Where is 46 as a perfect square? Or what two perfect squares is 46 between? It's between 49, which is 7, and it's between 49, which is 7, and 36, which is 6, but it's definitely closer to this end. Okay? If you wanted to, you could even say, here, hang on a sec, 36 to 49 is a jump of, 13 units. So it's actually, you could think of it as 6 10/13. Now the reality is it's not exactly 6 10/13. Now how come it's not exactly? Because the scale that I'm counting on here is linear, right? 6 and then 13 pieces, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and there's 7. So if I count by 13ths, because it took me 13 steps to get from 36 to 49, if I count by 13ths, I get to root 46, so this is root 36, this would be root 37, root 38, root 39, 40, 41, 42, 43, 44, 45, there we go, root 46, and then at 7, root 49. Oh, if only square roots worked this way. The reality, though, is that square roots are not even distances apart. It's not really a linear scale. That should make sense to you, right? Because if you think about y equals x squared and square root the other side, right, that's the same equation. Well, now it's the same equation. The graph for that would be, the graph for this equation would be just a sideways parabola. It's not a linear scale, it's a curve. So the distance between these points isn't really constant. It's changing. So even 10/13 isn't going to be exact, but it's going to be close. If you want a fractional estimate, you could say it's 6 10/13. Let's see how close that is. Where'd my calculator go? So what is, come on, clear everything. What is the square root of 46? 6.78. What is 6 10/13? It's a pretty good estimate. I'm off by 2/100. So there you go. So if you really want a good estimate, think fractions actually instead of decimals. If you're thinking decimals, of course you're just kind of guessing, right? You'd sort of just look at this kind of mentally and go, well, again, that's around, I don't know, 0.7 or 0.8 or something. And that's what it actually is. It's 0.8. So x is approximately equal to negative 5 plus or minus 6.8. So my two answers for x estimated, these are again my exact answers, 5 plus, negative 5 plus root 46 and negative 5 minus root 46, but my estimated answers are negative 11.8 when this is the negative answer, and 1.8 for the positive answer. And I'm looking at the book, that's what they have. And the book then reminds us that, oh yeah, these of course would be the x-intercepts if I were to graph this thing on a grid. Okay, so there's example 2. There's the keyboard, isn't it nice? Go away. There's example 2, example 3. Okay, what if a is not 1? Can I factor out the negative 2 out of everybody? No, not without having a fraction on that 7 and that 3. I don't want that. Neither do you. So we're going to have to complete the square. We're still going to have to deal with a fraction, but we won't deal with a fraction on the 7. We'll do this. We'll take out the negative 2, leaving this as plus 3 halves. And then we'll do this the way we did completing the square in chapter 3. We'll leave some space there for plus and minus, and then we'll kick the 7 over to out of the way, and we'll figure out what completes the square in step 1. So what completes the square? Well, I need half of 3 halves squared. So what's half of 3 halves? If you need to work this out on scrap paper, do it. That's 3 halves times a half, right? So that's 3/4 squared, which is 9/16. No, I don't want you to work these kinds of questions out with decimals. And there's 2 reasons for that. Reason number 1, what if I wasn't dealing with halves and quarters and 16ths? What if I had thirds or sevenths or 13ths? Right? Then I'd have repeating decimals. And right away, I've lost accuracy. I'll never know my exact answers because I rounded my decimals. Reason number 2 is that this procedure we're doing tomorrow is going to get us the quadratic formula. Yes, you finally get to use the quadratic formula, but you don't get to use it unless you can derive it. You have to earn the right to use the quadratic formula in my room. Okay, we just messed up our equation. We added something to it. Fixed. Now it's the same equation it was a second ago, right? Because I just added 0. Now, what do I want to do with that? Well, this part here, remember? I'm going to use my highlighter. I don't want blue. Give me a yellow. There we go. This part here is the perfect square trinomial, right? So that part we want kind of by itself. Oops, I'm still on the highlighter. So we're going to isolate that. So we're kicking this guy out of the bracket. But remember, if this thing's going to come out of the bracket, if I'm going to expand that out of the bracket, what do I have to do to it? I got to multiply it by the negative 2. So again, use scrap work if you have to. What's negative 2 times 9? Negative 9/16. Well, a negative times a negative is a positive, and 2 goes into 16 8 times, so that's plus 9/8. All right, next, let's figure out what the perfect square is, and let's combine our constants. So this is x plus, so now how does a perfect square trinomial factor? Remember, you know it's a perfect square trinomial because you built it. You picked this number to make a perfect square trinomial. So all you have to do is square root this number and you've got it. So there you go, it's 3/4. It's always kind of this step, right? So 3/4. Now this part, I might do this with scrap work too. 7 is 56/8, right? Because that's 7 over 1 and I times top and bottom by 8. So I have 9/8 plus 56/8 is 65/8. And now I'm ready to do my opposite operational algebra. Isolate x. What's the first thing that moves? 65/8. I minus it from both sides. What's the next thing I move? I divide both sides of the equation by -2. Careful, dividing by 2 is the same thing as timesing by 1/2. So I have this, right? Oh, and keep in mind too, it was a negative divided by a negative. That's why there's no negative anymore. What's the next step? I square root both sides. Now, square roots are exponents. And you learned back in grade 9 something called power of a quotient rule, which means you can do what? It means you can distribute the power into the top and bottom separately. So that means that I can do the square root of 65 and 16 separately. And then this 3/4 is getting minused from the other side. And isn't this nice? Actually, if you do this right, this always happens. I have a common denominator. And there is my exact answer. Or my exact answers, right? That is two numbers. -3 plus root 65 and then divided by 4, or -3 minus root 65 and divided by 4. And again, if I need an estimate, because say for example, I was using these as my x-intercepts and I want to graph them, where's the square root of 65? Oh, it's really close to 8, right? So I'm going to say 8.1. It's probably 8.0 something. I'll say 8.1. So this is x is approximately -3 plus or minus 8.1 over 4. So that's 8 is approximately, let's see, -3 minus, we'll do the minus one first. -3 minus 8 is -11, so -11.1 over 4. And the other answer would be -3 plus 8.1, so take 3 away from this 8. So it'd be 5.1 over 4. And then you could keep estimating that decimal if you want. You could actually divide the 4 into the 11 and figure out what the actual decimal place on that is. So let's see, 4 goes into 11, 4 goes into 11 twice, with 3 left over. And how many times does 4 go into 31? About 7, and then that would leave another remainder of 3. So 2.7, so I might as well just round that to 2.8. Good enough, 2 decimal places. I mean, how accurate can you graph anyway? That'd be the only reason you'd be doing this, right, is because you want to know where the x-intercepts are. And then what's 5.1 divided by 4? 4 goes into 5 once, and then leaves behind a remainder of 1, so 1.3. So it'd be, so here's, maybe I should write this down just to show you what I'm thinking, right? I'm basically thinking that. 4 goes into 5 once, bring down the 1, put a decimal there, bring down the 1. So 4 goes into 11 twice, 2 4s is 8, 3, and I know right away 4 goes into 30 more than 5 times, so that means this 2 rounds to a 3. And that's my 2 answers. And now I'm going to look at the book. Is that what they got? I'm on the wrong page. Hold on. Oh, they rounded to 2 places, but yeah, pretty much. They said -2.77 and 1.27. I rounded to 1 place. And I didn't touch a calculator. Okay, so there we go. So I don't think I'd ask you to do this part, but certainly on the next test, one of these, where I want the exact answers, no calculator, pretty much guarantee you one like that. All right, now let's actually do one with a problem solve. A defender kicks a soccer ball away from her own goal. The path of the kicked soccer ball can be approximated by this curve, where x is the horizontal distance traveled in meters from the goal line, and h is the height in meters. You can determine the distance the soccer ball is from the goal line by solving the corresponding equation. So how far is the soccer ball from the goal line? Express your answer to the nearest tenth of a meter. Okay. Now I'm going to let myself use a calculator, but I'm not going to let myself use a graphing calculator. We're going to do this by completing the square. So what were the steps? It wasn't so hard. I know there's probably people are going, this was hard because your fraction skills maybe aren't perfect. But this was a fairly easy one, really, compared to the one we're about to do, because these are fairly friendly numbers, right? Eighths, sixteenths. Those aren't the ugliest fractions in the world. Look at the numbers we're dealing with now. Nasty decimals. We're going to need calculator help for this one. So step one is to factor out 0.06. So that's x squared. And now, what number goes here? How do you factor something out? What are you really doing? What's the actual operation mathematically that you're doing? Think of an easier example. If you have 2x squared plus 4x and you factor out the 2. Maybe 4 is a bad example. 8. There we go. You factor out the 2. What goes there? A 4. Now ask yourself, what did you do to 8 with the 2 to get to a 4? You went divide. It is. Factoring at the end of the day is dividing in a sense, right? So I'm going to divide 3.168 by negative 0.06. I already took care of the negative part. Or no, I actually haven't taken care of the negative part. I wrote it down wrong. There, that took care of the negative part. Now I need my calculator back. And now it's in the way. And now it's still in the way. And it doesn't want to go where I want it to. What if I do that? Ha! There you go. Okay, so clear, 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 clear. 3.168 divided by 0.06. 52.8. Oops. 52.8x. And then, of course, we leave ourselves some space. We kick that constant kind of out of the way. We'll deal with him later. What completes my square? Think procedure. What did I do to this number? Last three examples? I took half of it, then I squared it, right? So that's what I'm going to do to that number. I'm going to take half of it, and then I'm going to square it. 696.96. But I'm going to minus it right away so that I haven't changed my equation. All right, now, remember, same as the last example, this part here is my perfect square trinomial, right to there. This part here is my perfect square trinomial, so don't mess with it. What happens to this number? We kick it out of the brackets. We cast it out. So how do we do that? We have to times it first by that. Now luckily, I still have that number on my calculator. So I'm timesing it by negative 0.06. So times by negative 0.06. So it's actually negative 41.8176. So it's actually negative, that's how good my memory is, 41.8176. 41.8176. Yes. Oh, you're right. It should. It was a. You're right. Thank you. It was a negative times a negative. There you go. Look at that. I made a mistake. But don't forget. We still have another number too. This guy. Yes, you're right. We multiplied this number by that number, which is a negative. Which is a negative times a negative. Okay. Now I have to combine those two numbers. I'll use my calculator to help me again because there's a bunch of decimals on it. Oh, but I don't actually want a negative. That was a mistake. So I'll just times by negative 1. There we go. And move up a little. There we go. So it's that number minus 35.34. 6.4776. Oops. Oops. 6.476. Oh, I just clicked on a fatter pen too. Okay, let me just double check that number because I'm very good. Oh, see, look at that, 4776. 776, there we go. Okay, so that takes care of the constants. Meanwhile, inside the bracket, oh, I've kind of forgotten that this is an equation. It's got 0 on the other side. So 0.06 times, and let's put that in here. Okay, so this is now x. And what goes here again? How did we find that number before? It was super easy back when this was in the days when it was minus 6x plus 9. You've factored that thing many times since grade 10 probably. What was the actual process though that found me this number? It was the square root of that number, right? So, and this is a minus, so this has to be a minus. So I'm now going to have to go to my calculator and go to that 696.96. So 696.96. Oh, wait a minute, I want to square root it. Square root. 696.96 square rooted 26.4. There. That's the perfect square trinomial. Factored. That's the vertex form, right? If I needed the vertex for this question, I've got it now. I don't. What do I actually need? I need the x-intercepts. How do I know I need the x-intercepts? Because how far does the soccer ball travel before it hits the ground, right? How far is the soccer ball from the goal line when it is kicked? You get the idea. We need the x-intercepts. A is the first x-intercept, the smallest one. B is the biggest one. Okay, so next we are going to move that to the other side of the equation. And we're just going to do algebra with ugly decimals. But we've got our calculator to help us. It's not so bad. And I already have that one of these numbers on my screen, but oh well, I can't use it this minute. So I'm going to now divide both sides by negative 0.06. So I'm going to go back to the calculator and go negative 6.4776 divided by negative 0.06, 107.96. Now it's the square root step. Oops. And x equals 26.4 plus or minus the square root of 107.96. So now I have to figure out those two numbers. I need them both to solve these two questions. So x is, all right, advanced calculator techniques here. So 26.4 plus the square root of my answer. So that's 36.79. And I'd have to go back to the question to remember myself what we're in. Are we in feet or meters? We're in meters. And x equals the other answer would be the minus answer. And here's what I'm going to do for this one. Check this out. You have an answer button here. Most calculators, or some calculators, your fancier ones like this, have an entry button. And if you have an entry button, you can just go back and change plus to a minus and hit equals, and you don't have to repunch things. Ha ha ha. 20.33 meters. And there's the two answers. Okay, hang on a sec. Did that work? 20.33. I'm looking at the book. I've got this answer. I think I might have goofed that one up. Hang on. 20.33, yes. 26.4 minus 107.96 square root. You know what? I'm thinking the calculator might be lying to me here. It did. It took the answer to the other one. Look at that. Okay. My calculator isn't working the way I thought it would. I have another calculator that when you do entry, it automatically goes back to the entire entry. There we go. That's the. I kind of knew that was too close together. Good thing I looked at the example in the book. So 16.01 is the right answer for this. Interesting. Okay, so that didn't work the way I thought it would. So there we go. What do we know about these two numbers? Well, think about this. This is a graph. This is a very rough graph. This is 16.01 is the first x-intercept, and then it goes up, and then it goes down to here at 36.79. This vertex, if I wanted it, was 26.4 comma, what was the other number on that? 6 point, no, what was it again? Where are we? There we are. 26.4 and 6.4776. So there we go. That's all the information I have about this parabola. Now, what solves the problem? Look at the problem again. How far from the goal line is the soccer ball when it's kicked? That's the goal line, we're going to assume, 0. So the answer to A would be 16.01 meters. And the answer to B, is the answer to B this number? Look at the B question again. How far does the soccer ball travel before it hits the ground? I think they mean horizontally. So is that this number? No, how far it travels is the distance between them, right? So I'm going to say that that's 36.79, oops, 79, minus 16.01, which is 20.78 meters. That's how far it is from there to there. And there's the kind of question that you will for sure get next week on the test. An ugly complete the square where you got to use your calculator. Okay, so there we go. Those are the examples I wanted to go through today. And now you can work on some of these for yourself. I'll stop the video.